All right, this is Honors Algebra 2 Pre-Calc. We are doing 5.5 in Pre-Calc. This is half angle, sum to product, and product to sum. So this is legit the use but don't memorize video. It's not that some of these aren't useful, and it's not that you can't logic your way through and figure these out from other information you have. It's just that, honestly, I have never really had to memorize them. So just as an example of what I mean by logicking through this, this is the power-reducing formula for sine. Let's just call it sine squared, right? So sine squared of x. And we know that it's 1 minus cosine of 2x all over 2. If you solve for sine, you would get that this is plus or minus the square root of 1 minus cosine of 2x over 2. That's this formula, right? Like that's this, because this angle is supposed to be half of this angle. Well, that's totally what this says. This is 2x, this is x, this angle is half of this angle. The reason it's a plus or minus is because you took a square root, and whether it's a positive or negative will really just depend on what angle, what quadrant the angle theta over 2 falls in, right? Is the sign negative or positive based on whether you're in quadrant 1, 2, 3, or 4. But again, I don't really need you to memorize those. I just want you to know how to use them if you see them, right? So you can logic through a lot of these. So we're going to go ahead and use the half angle formula and your unit circle knowledge to find the exact value of this. So here's the idea. 105, which we're going to call theta over 2, is not on the unit circle, right? But if that's theta over 2, 210, which is double 105, is on the unit circle, right? So the cosine of theta over 2 is plus or minus the square root of 1 plus cosine theta all over 2. So we're just going to go ahead and use that value. And we know where 105 is, right? So 105 lives somewhere around here. So I know that in this situation, because of where 105 is, I know that 105 is in quadrant 2, that I want the negative version of this. So my cosine of 105 degrees is going to be, and so the cosine of 210, right? So 210, right? This is 210. This is a negative root 3 over 2 comma 1 half, negative 1 half rather. So that's a negative root 3 over 2, right? So we're going to get that this is negative square root of 1 minus a root 3 over 2 all over 2, right? Which is going to be a negative. If we get a common denominator here, this is a 2 minus root 3, both of them over 2, all over a 2 again. So I get that this is the square root of 2 minus root 3 all over a 4. Or if you want to make this a little bit better, I get that this cosine of 105 is a negative square root of 2 minus root 3, so it's a root in a root, all over a 2, and that's the exact value of the cosine of 105. Now, we've learned other ways to find the value of the cosine of 105. We learned that we could use like 60 plus 45 to find the cosine of 105, and that's totally fine. And we could use the u plus v formula, and you get a number that is equal to this, but a slightly different look, right? So, but you could check in a calculator that the two of them are the same. So that's not to say this is the only way to find cosine of 105, and honestly, it's not the way I would find cosine of 105, but just to show you that this is how a half angle formula works, okay? So let's go ahead and work on our next problem. All right, so again in P6, we're being asked to use the half angle formula and unit circle knowledge to find the exact value of this expression. I do want to point out that just like we saw in E6, there's a whole other way to do this using the sum and difference formula, right? Like you could use 45 degrees plus 30 degrees and pretty quickly find a value that's exact for sine of 75 degrees. But here the goal is to use the half angle formula, right? So you might recall that the sine of theta over 2 is plus or minus the square root of 1 minus cosine of theta all over 2. So that's the formula that we're using, right? If you think about where 75 degrees lives, right? 75 degrees lives here in quadrant 1, right? So what that says is I'm using the positive version, right? Because in quadrant 1, sine is positive, right? In quadrant 1. Because it's the y value. So I know I'm using the positive version of this, and then basically my situation here is that I'm calling this theta over 2 75, right? So 75 degrees is my theta over 2, meaning my theta is $1.50, right? So 150 on the unit circle is right here. It's 5 pi over 6, right? So the coordinates are negative root 3 over 2 comma 1/2. So to find the sine of 75 degrees using the half angle formula, right, I'm going to do the positive, because I know I'm in quadrant 1, square root of 1 minus this negative root 3 over 2, all over a 2, right? So that's going to be plus or minus the square root of 1 plus root 3 over 2, all over 2, right? Oh, sorry, and I don't need the plus or minus. I just need the plus. My bad, just plus. So plus the square root of, this was a 2 over 2, right? Because that's 1 is, so I'd get 2 plus root 3 all over 2 again, which is over 4. So you're going to end up getting that the sine of 75 degrees is the square root of 2 plus, oh, sorry, my bad. Didn't need the giant square root, was trying to simplify it. Is that root 4 on the bottom can become a 2, so it's going to be the square root of 2 plus root 3 on the inside of the root, and then all over a 2 that is not inside the root. And again, there's another way to get an exact value for that, and you can certainly do that, but in this case, we were being asked to use the half angle formula to figure that out. All right, so for example 7, we're going to use the half angle formulae and the given triangle, which is not drawn to scale, but we can assume is in quadrant 1, to find the exact value of the trig function I'm given, which in this case is cosine of theta over 2. So the formula for cosine of theta over 2, knowing that this theta is in quadrant 1, right? Half of an angle in quadrant 1, meaning half of an angle between 0 and 90 degrees or between 0 and pi over 2 radians, is still going to be a positive value. So we don't need the negative, right? So we know that theta over 2 is also in quadrant 1, so we can say positive. And this is going to be the square root of 1 plus cosine of theta all over 2, right? So once we know this, right, so once we know this, we need to figure out what the cosine of theta is. Like, that's the value I need to answer this, right? So I need this value. Well, in order to find the cosine of theta, I'm going to have to find the missing side so that I can do adjacent over hypotenuse. Well, conveniently, this is a 3, 4, 5 right triangle, right, with the hypotenuse being the 5 and the two legs being 3 and 4. So what I recognize is that the cosine of theta is going to be a 4 over 5. And once I know that, I can pretty much go ahead and plug into my formula and get a value. So I'm going to get, this is the square root of a 1 plus 4/5 all over 2, right, which is a square root of, this is a 5/5, right, so 9/5 all over 2, right, or the square root of 9/10. And that's about as nice as it gets. Like, you can clean it up if you want. If you want to make this a root 9 over a root 10, to make this a 3 over root 10, and then rationalize, you're certainly welcome to do so. Like, this is probably the best answer, but all of them are okay, right? This is okay, this is okay, this is okay. This is probably the most sort of classical textbook answer, is to clean that up a little bit. All right, so moving on. Same idea, right? We're going to assume that a triangle is in quadrant 1, so I see a 5, 12, that makes the hypotenuse a 13, right? 5, 12, 13, or you could do Pythagorean theorem to figure that out. Because I'm in quadrant 1, right? If theta is in quadrant 1, then half of theta is also a positive angle in quadrant 1. So I know that I want the positive square root of 1 minus cosine of theta all over 2. So I need the cosine of theta, which I can see is adjacent over hypotenuse, right? So I'm going to get that this is a positive square root of, this is a 1 minus 12/13 all over 2. Well, that's 13/13 minus 12/13, right? So I'm going to get that this is 1/13 all over 2, which means I get the square root of 1 over 26, which is not wrong, but if you want to clean it up a little, it's a root 1 over a root 26. So 1 over root 26, the rationalized version would be root 26 over 26. This is probably the best answer, but this is also okay, right? Like, this is not wrong. This is probably the best, classic textbook answer. All right, moving on. So now we're really going to lean into just using formulae and not memorizing them. I don't have any of these memorized, not at all, not once in my whole life. If you made me memorize them for if you said, Hogan, I bet you can't memorize that, I would memorize it just because you told me you thought I couldn't, but that's about it. So this is when you have a product of two trig functions and you want to split it into a sum or difference, right? So I'm not going to suggest that you have to memorize this. I'm going to suggest that you have to be able to use it. And to back that up, I'm going to show you that I'm literally putting the formulae right next to the problem. I just want to make sure that you can match which one you're looking at. So I have sine of something, cosine of something. So I look and say, oh, that's this one, sine of something, cosine something. So in this situation, my u is the 5 pi over 12, and the v is going to be the pi over 12. I just need you to be able to use this formula. So it should be 1/2 the sine of u plus v, so that's a 5/12 plus a, 5/12 pi plus a pi over 12, right? So u plus v, plus the sine of u minus v, which is going to be the 5 pi over 12 minus the pi over 12. So that's a 1/2 the sine of 6 pi over 12, which we'll deal with in a sec, right? 6 pi over 12, plus the sine of 4 pi over 12. Now, both 6 pi over 12 and 4 pi over 12 are on the unit circle, right? Because this is a 1/2 times the quantity sine of pi over 2, which I can find in the unit circle, and sine of pi over 3, which I can find on the unit circle. So pi over 2 is here at the point 0, 1, so the sine is the 1, right? And pi over 3 is here with the coordinate 1/2 comma root 3 over 2. So the one I want is the root 3 over 2. So my answer is going to be a 1/2 times the quantity 1 plus root 3 over 2. If you clean this up, this is a 2/2, right? So this is a 1/2 times 2/2 plus the root 3 over 2, if I get a common denominator, would look like that. So I end up with an answer that looks like this. And I wasn't technically wrong my bad. I wasn't technically wrong at this moment, like that's an answer, but this is probably the best answer. Again, I'm not going to expect you to memorize this. I don't have it memorized. I need you to be able to look at a problem and say, oh, here are some trig identities that would be useful. That's it, right? You'll see that on all of these examples and practice problems, I have the formula sitting right here because I don't need you to have it memorized. I just need to be able to look at it and see which one matches. So here I have cosine and cosine, right? So I look for the one that is a cosine and a cosine, and I say, oh, hey, this is the one I'm using, right? And I see that the u and v just stay in order, right? So u is the 7 pi over 4 and v is the pi over 4. So looks like they're both going to be cosines, right? So it looks like this is going to be 1/2 times the quantity cosine of u minus v. Well, that's going to be 7 pi over 12, over 24 minus pi over 24, right? So 7 pi over 24 minus pi over 24. Plus cosine of u plus v, which is going to be 7 pi over 4 over 24 plus pi over 24, right? And again, both of those should turn out to be pretty nice numbers, right? Because they'll both be on the unit circle. So this is a 6 pi over 24. Well, 6 pi over 24 is just a pi over 4, which is on the unit circle. And this turns out to be an 8 pi over 24, which is also on the unit circle because it's a pi over 3, right? So if we look, here's pi over 4. Both points are root 2 over 2's, right? They're both coordinates, so that's the one I want. And at pi over 3, I want the 1/2, right? I want the 1/2 because it's the x coordinate for cosine. So I get this is a 1/2 root 2 over 2 plus 1/2, which seems to be a root 2 plus 1 all over a 4, right? Because it would be 1/2 times that 2, right? Like 1/2 times the 1 over 2, rather. All right, so again, I don't need you to memorize it. I just need to be able to use it. So last two, we're going to do, not last two, because we'll do a few more of these. We're going to do sum to product and product to sum, same thing, right? So here I have sine, cosine, right? Well, I look and say, oh, that's this one, sine, cosine, right? So my u is x plus y, my v is x minus y, and my job is just to be able to use this formula to clean this up. So this is going to be a 1/2 sine of u plus v. Well, when I add x plus, so this is going to be x plus y, right, plus x minus y, right? And then plus sine of, and then this is u minus v. Well, that's going to be x plus y minus the whole quantity x minus y, and we'll deal with that in a sec, okay? So I'm going to get this a 1/2. Well, this ends up just being a 2x because the y's have opposite signs, so they cancel. So sine of 2x, right, plus this one, when I distribute the negative, means that the x's are going to have opposite signs, but the y's will both be positive. So this is going to be the sine of 2y, and that's about as good as it gets, right? I can't get a number for it. I don't know any more information. All I did was clean this up. All right, same idea. You're going to try P9. Again, you're going to look for the formula. Here I have a sine and a sine, so I say, oh, hey, that's this one, right? My u is theta plus pi. My v is theta minus pi, right? So I'm going to get that this is 1/2 cosine of u minus v. Well, u minus v, right, would be a theta plus pi minus the whole quantity theta minus pi. Well, when I distribute that negative, the thetas end up being a positive theta and a negative theta, they both cancel, and I just get a 2 pi, right? Minus cosine of, and then I need u plus v. Well, when I add u plus v together, the pi's are opposite signs, right? So this would be theta plus pi plus theta minus pi. The pi's are the same value but opposite signs, so they cancel, and I just get a 2 theta, right? The only difference here is that cosine 2 pi is a number I know. This is a number on the unit circle, right? 2 pi is at the coordinate 1, 0, so I get that this is a 1/2 times a 1 minus cosine of 2 theta. And that's great. You can leave your answer like that. If you want to make it something like a 1 minus cosine 2 theta all over 2, you certainly could. That's also fine. All right. Okay, so then there are these product to sum formulae, which that we just did, and now there's sum to product. Again, I don't have any of these memorized. You certainly don't have to. You can figure them out if you use the one set to figure out the other set and to use a bunch of trig identities, but there's just not really a reason to do so. So when we use them, which we're going to do for the last 4 problems, you're just going to match, right? So I see I have cosine minus a cosine. That's this situation, right? So cosine minus a cosine, so I'm just going to say, cool, my u is the pi over 12, my v is the 5 pi over 12, that's it, and I'm just going to match this, right? So this is going to be a negative 2 sine of, so u plus v all over 2 is going to be a 6 pi over 12 all over 2, right? That's u plus v all over 2, times the sine of u minus v, right? Well, u minus v is going to be a negative 4 pi over 12, right? Because it would be pi minus the 5 pi, right? So u minus v is going to be a negative 4 pi over 12 divided by 2. And then we're just going to clean it up, right? So that's multiplication. So this is a negative 2 sine of, this is a pi over 2, which is a pi over 4, right? And this is a negative pi over 3 over 6, which would be a negative pi over 6. So then I just need values for this. So here's pi over 4. At pi over 4, both the x and y coordinate are root 2 over 2. So that's definitely this one, right? It's pi over 4. There we go, all right? So it's a negative 2 times a root 2 over 2, right? And then negative pi over 6 means go backwards pi over 6. So this is the same spot as 11 pi over 6, right? It's the same spot, negative pi over 6 and 11 pi over 6. So that sign value is going to be a negative 1/2, right? So this is a root 3 over 2, comma negative 1/2. So it's the negative 1/2 is what I want. So after all that work, I seem to get that this is, I'm just going to use the negative 2 and the negative 1/2 to cancel each other out, and I seem to get a root 2 over 2 as my answer, right? Again, I don't need you to memorize this, right? So I look and see I have sine of u plus sine of v, so that's this one, right? And then it's just my job to match the formula. So I get that this is 2 sine of u plus v should be a 6 pi over 12. So 6 pi over 12 over 2, right? Cosine of u minus v should be a negative 4 pi over 12 over 2, right? So that's going to be a 2 sine of, this is pi over 2 over 2, so that's pi over 4 again, which we saw in the last one. This is a negative pi over 3 divided by 2, so that's going to be a negative pi over 6. So we're actually using the exact same spot as last time. This one, which was root 2 over 2, comma root 2 over 2. And negative pi over 6, which is the same as 11 pi over 6, that's a root 3 over 2, comma negative 1/2. Sorry, that kind of got messed up. It's a negative 1/2. So since I want the cosine, I want the sine of this one, and I want the cosine of this one. So I'm going to get that this is root 2 over 2 times root 3 over 2, right, which seems to be a root 6 on top of a 2, because one of the 2's cancels. And that's about as good as it gets. All right, last 2 problems, and really, again, we're just practicing using these things. You don't have to memorize them. I see that I have sine plus sine. Well, that's this one, right? So I'm going to use 2 sine of x plus 5x all over 2, cosine of x minus 5x all over 2. So I think I get 2 sine of, this is a 6x over 2, so that's a 3x. And this is a negative 4x over 2, so that's going to be a negative 2x. And that's it. You don't have to do anything else. One of the reasons I wanted to put these examples in here, even though you're literally just looking up information at a table, is depending on what job you pick, it is important that you're resourceful in your brain and that you can use information to make mental leaps. But if you're somebody that's designing a building or a bridge or something else that involves a lot of math and physics and science, please don't just do it from your head. Like, look up formulae, double check that you're right, make sure you're not missing a negative or you're multiplying by the right number. It's a valuable resource to be able to take something that's handed to you in a book or from the internet when you're looking for values and then use it, right, and use it correctly. So that's part of the reason we're doing this. So I see that I have cosine plus cosine, so I'm going to use this formula, right? So this thing is going to equal 2 cosine of u plus v should be a 4x over 2. Cosine of u minus v should be a 2x over 2. So I just get that this is 2 cosine of 2x cosine of x. And that's it. And I don't need any more from you. And you're just making sure you know how to use them when they're handed to you. All right, and that is the end of 5.5.